Hi, this is Thomas. Welcome back. Our topic is integration. This is integration using substitution, example 2. Our requirement reads, use the substitution u equals sine x to find the integral of sine 2x squared times cosine x with respect to x. Going to our algorithm, step 1, identify function type. We're given a substitution, so we're dealing with substitution to replace the x terms with u terms. 2. Apply integration rules. Let's work through our substitutions. The first we're given, u equals sine x. The derivative of sine of x, du over dx, is cosine x. Looking at the original integral, I have a dx, a with respect to x, that I want to isolate in this equation. So I'll multiply both sides by dx. We have on the right cosine x with respect to x. Now notice in the original integral we have cosine x and with respect to x. So now with the single substitution du, we're going to replace both of those x terms. What's left is sine 2x squared. Here we need a trig identity. The clue is that the argument of the sine function is 2x, but we're dealing with a substitution of sine x. Referencing identities either from memory or from the formula booklet that you'll have during the exam, I find that sine of 2x equals 2 sine x cosine x. Now I'll rewrite my integral before substitution. Sine 2x squared will now be 2 sine x cosine x squared times cosine x with respect to x. Then expanding the first term, the integral of 2 squared is 4. Sine x squared is sine x squared. Cosine x squared is cosine x squared times cosine x with respect to x. Now what I see is I have a substitution for sine x, and I have a substitution for cosine x with respect to x. What I need to work on now is cosine x squared. Since I have the substitution u equals sine x, I want to work on getting cosine x squared into a sine term. And I have an identity for cosine x squared, and that identity is, let me go back, by the way, to the sine 2x identity. I have an equal sign. I want to put an identity sign there. An identity with cosine x squared is an identity with 1 minus sine x squared. You'll see that in the formula booklet as cosine x squared plus sine x squared equals 1. With a manipulation, we can get to the identity given on the screen. So now again, rewriting our integral, we have the integral of 4 sine x squared times, we're going to replace cosine x squared with 1 minus sine x squared times cosine x with respect to x. Now at this point we can complete our substitution. I'll bring the 4 outside of the integral. 4 times sine x squared. We'll replace sine x with the given substitution u squared, times 1 minus, again the substitution for sine x is u squared, times cosine x with respect to x. Those two terms are both replaced with the substitution du. I'll distribute the u squared to get to 4 times the integral of u squared times 1 is u squared, minus u squared times u squared is u to the power of 4 with respect to u. And now I'll complete my integration. 4 times u squared becomes u to the power of 3. We'll multiply by 1 over the new exponent, 1 over 3, minus u to the power of 4 becomes u to the power of 5, and we'll multiply by 1 over the new exponent, 1 over 5. adding on our constant of integration plus c. This completes step 3. Step 4, simplification. I'll distribute my 4. 4 times 1 over 3 is 4 over 3. U to the power of 3. Minus 4 times 1 over 5 is 4 over 5. U to the power of 5 plus C. And finally, I'm going to re-sub. This is a substitution problem. I've gone from working with x to working with u. Now I need to get back to x. So we have 4 over 3 times u to the power of 3. Looking back at the original substitution, u equals sine x. So we have 4 over 3 times sine x to the power of 3 minus 4 over 5 u to the power of 5 becomes sine x to the power of 5 plus c. This is an indefinite integral. There are no limits of integration, so step 5 doesn't apply. Using the given substitution, we found the integral of the given expression as 4/3 sine x cubed minus 4/5 sine x to the power of 5 plus c. We've completed our requirements. This concludes integration with substitution example 2.